Welcome to the next session of ANSYS APDL. In this session, we are solving another numerical for beam analysis using APDL. This is a simply supported beam with one end hinged and the other end is having a roller support. We can see certain forces on the beam. They are point load, but they are applied at an angle. So I have already made the FBD here. So I will be making the beam and applying the load as per the FBD. So let's get started. I'll first go to preferences, structural, OK, preprocessor, element type, add, edit, delete, add, beam, to node, OK, close. Then I'll go to material properties, material models, structural, linear, elastic, isotropic. I will apply Young's modulus as 2E5 and Poisson's ratio as 0.3. Okay. Then I'll go to sections, beam, common sections. I'll apply the breadth as 30 and the height as 30. Okay. Then I'll go to modeling, create key points in active CS. The first node is always at 0, 0. The second one, that is point B, is at a distance of 1 meter from A. So the second one is at a distance of 1000. Then the third node C is at a distance of 2.5 from the start. So that makes it to 2500. Node 3, apply. Then node 4, that is point D over here, is at a distance of 4.5. So this becomes 4500. Apply. And the fifth and the last node is at a distance of 6 meters from the start. So this will be 6000. Okay. So 5 nodes are created. Then I'll go to lines. Lines, straight line, okay. Next I'll go to meshing, size control, manual size, global, size. Let me choose the number of element divisions as 10, okay. Then I'll go to mesh, lines, pick all. So the meshing is done. Next, I'll go to plot controls, numbering, element numbers. Okay. Now, I'll apply load on the beam, define loads, apply structural displacement on key points. At node A, it is hinged. So, I will choose all of them as 0 except rotation about Z. Next, at the last point, I am going to apply roller. So Uy will be 0. Okay. Then I'll apply these loads that I have already calculated at point B, C and D. At point B, there is 2 kilonewton downwards and 3.464 kilonewton towards the right. I'll click on force on key point. So this will be 3464 Newton. Apply, and at this point again I am going to apply the force in Y direction, that is 2 kilonewton, so minus 2000. Okay, this is point B. Next, at point C, the force value is 4.243 kilonewton. It is in the downward direction and the same value is towards the left as well. So I will apply on key point for C along the y-axis. It is minus 4243. Apply. At the same point along the x-axis is the same value. At point D, 4 kilonewton is in the x-axis Okay, it's positive. Apply. Along the y-axis, the value is 6.928. So it is minus 6928. Okay. So I have applied all the forces and the boundary conditions. So this completes my loading. Next I'll go to solution, solve, current LS. Okay. The solution is done. So I'll close the box. Next I'll go to general post processing. I want to plot the results. I want to see the deformed shape. Okay, so this is how the deformed shape looks like. I'll go to contour plot, nodal solution. I want to see the degree of freedom, displacement vector sum. I'll choose deformed shape with undeformed model. This is how it looks like. Now if I want to plot the shear force and the bending moment diagram, so I'll go to element table, define table, add by sequence number 3, 6, 16, and 19. I'll go to plot results, line element resolution. I'll change the J value to 16. Okay, this is the BMD. So we can see the BMD here. It looks exactly same. And the value over here, that is maximum, is 11.67. So when I check here, the red value is 11.67. This is in kilonewton meter. So when I convert into Newton mm, I have to divide by 10 raised to 6. So these are the same values that I obtained. You can check the other values as well. Now let's talk about the SFD. So this is 6 and 19. Okay. This is how the SFD looks like. When I check with the solution, it's approximately the same. It's only the alignment of the area. It could be positive or negative based on the sign convention. So here I can see it is 5.87. Let's check this value. This is 5.87. This red value is what we are checking. It is 7.3 kilonewton. Here it is 7.29. So it's exactly the same. Now I also want to plot the AFD as it is seen here. So I will go to element table, define table. I will add two more values. One is 1 and the other one is 14. So now I'll go to plot results, line element resolution, and I'll choose here 1 and 14. Okay. So this is how my axial force diagram looks like. So let's check these values and diagram. So the diagram looks exactly the same. I'll check the values. Here it is 3.22 and this yellow value over here is, you can see the value over here is 3.52. So it's close. Okay, so this value, if you see here, it is approximately 0.228. This red value is 4000, which means it is 4 kilonewton. This is exactly the same. So this is how you're going to tally the values with your numerical solution to know if the solution by ANSYS method is correct. I hope you have understood the procedure for solving this numerical. If you have any doubt, please write to me in the comment section. See you in the next session. Thank you.